Hello everyone and welcome to Frogs, Fleas, and Painted Cubes 4.3. Today we're working on page 76 of our textbook and we're working with painted cubes. We finally get to see the last part of our name for our textbook, the painted cubes. Today's learning target is I will be able to correctly explore quadratic functions and other functions. ACEs today begin on page 83, 19 through 21, 33 through 34, 37 through 40, and 53 through 54. So we're going to be dealing with a new type of function that we haven't dealt with in the past, and that's going to be cubes or cubic, and that's going to give us a different type of graph, going to give us different patterns that we're going to want to look at. And to kind of lead you into this, let's take a look at a short video that will hopefully help lay the groundwork for this.
You have 15 minutes to wrap up your art projects if you want them to be considered for the gallery. You have 5 minutes left. How does Hector know where to put each type of cube in order to put his project back together?
Okay, so Hector wants to know how to figure out how to put his cube back together. We don't so much need to help Hector as we need to be able to figure out how to know how many of each type of cube is within the large cube. So Hector painted his cube. He wanted it to be nice and pretty. Then it fell apart. Well, what are one of the ways we can look at putting things back together? He needs to uh, the object, I guess, is that he wants to put the puzzle back together so the cubes have no unpainted faces showing. So when Leon examines, or Hector examines the centimeter cubes, he notices that some are painted only on one face, some on two faces, and some on three faces. And then there's a whole bunch that aren't painted at all. So the question really is, for any size of painted cube, what kind of equation tells you how many cubes will be painted on one face, two faces, three faces, and zero faces? In order to help you do this, in problem 4.3, on your ACES sheet there is a table, and it looks just like this, and we will be filling out this table to help us find, patterns, to then help us to come up with equations that will be able to predict how many of each type of cube will be needed depending upon the size of the cube. So in this problem, you'll investigate smaller versions of Leon's puzzle. The cube at the right is made of centimeter cubes. The faces of this cube are painted. Suppose you broke the cube into centimeter pieces. How many centimeter cubes would be painted on, first of all, three faces? Well, with this one, three faces is going to be each of them. Okay, that's one face, that's two face, that's three faces. Okay, these are all corner pieces, and the corner pieces have three faces. All of these are corner pieces, so they're all going to have three. So you have 8 for this one, none, none, and none. So as we're filling out our table up here, or I'll go to the next page, might be easier to see. When we have an edge length of 2, we're going to have 8 of them that have three faces, 0 that have 2, 0 that have 1, and 0 that have 0. And it wants to know what's the number of total centimeter cubes. Well, we'd add this all across and we would get 8 here. Obviously, it's going to get bigger as the cubes get bigger. Oops, let me go back. Then we go to 2, and it wants us to answer the questions for each of these cubes like we did up here of how many have 3, how many have 2, how many have 1, how many have none. And that's where the table comes in to help you record all of that data. This one is 3. Of course, we have our edges, our three faces here. And guess there's going to be 8, just like there was with the other ones. Then we have cubes that have two faces painted, like this. Those are two faces. And then we're going to have cubes that have one face painted like this. Okay, that's just one face painted. Now right behind that, there's another cube. That cube that you can't see has 0 faces painted. So you would record how many of each one of these that you find in your table, total them all up to see how many you get, and we'll do that for this four-sided, 5 or length of 4 centimeters, 5 centimeters, and 6 centimeters, and fill out your table. And then we're going to start to look at patterns again. What do you see that's similar? What's different? And from there, we want to be able eventually to come up with equations for that. So part B says study the patterns in the table, describe the relationship between the edge length of the large cube and the total number of centimeter cubes. Describe the relationship between the edge length of the large cube and the number of centimeter cubes painted on each of these 3, 2, 1, and 0 faces. Decide whether each relationship in parts 1 and 2 is linear, quadratic, exponential, or none, and how you know that. Then write the equation for each relationship in question B. Tell what the variables and numbers in each equation mean. Then sketch a graph, or if you want to use the color calculators, you can go ahead and do that. So quite a bit undertake and get a grasp of here, but hopefully 4.3 is going to open you to some new information. And let me see if I have, yeah, here's our homework, our ACEs. Okay, 4.3, 19 through 21, 33 through 34, 37 through 40, and 53 through 54. Might be a little challenging, but I know you guys are up for it, and I look forward to your questions and comments in class.